All right, you're going to want to turn your volume down because I think I got my microphone working better. Sorry if I just blew your speakers away. All right, this is the second page of the Sharpless epoxidation reaction. And so we're going to go over this in a little more detail, in particular in regard to the chiral catalyst, whether you're using the SS enantiomer of DET or the RR. And the SS is sometimes called the minus. All right, so here's the exact structure. We did this on the previous page, that the SS enantiomer of diethyl tartrate is the minus, or levorotary, when you measure it with the polarimeter. So instead of always writing out SS, sometimes you'll see just the minus. And that the RR is the plus when you measure with the polarimeter, and that is again for dextrorotary. I didn't have room to write that on the previous page. Sometimes it's called dextro. All right, so here is this one, and there is that one right there. And if we just use one chiral compound, again, it's just there at about 10%, it bonds with the titanium and kind of forms this catalyst structure that's proposed. It's in your textbook. I'll show you in a minute. It hasn't been proven to be that exact structure, but it forms kind of a clamp where when your peroxide oxygen is added, it's that O that gets added, it can come from either the top face or the bottom face. It turns out, if we're careful in how we always draw our allylic alcohol structure, we have to kind of draw it in a certain orientation, that we put the OH group in the bottom right hand corner. So you actually take the alcohol and you put it down here. And then you draw your alkene and the other substituents. And if you always carefully draw it that way, if you're using the minus, the guy that has these two, right, coming out at you, it comes from the top face. The O approaches from the top face, right? O ends up like so when you use this one. That's how I remembered it. Solid, solid. And then if you use the minus, if you use the plus enantiomer where they're going away from you, you get the other enantiomer of your epoxide again, where the O's end up. You know, the O is below the plane, so here it's underneath your sheet of paper, and here it's coming out at you. So that's kind of the mnemonic to always draw it a certain way. You'll get the products drawn the right way. You want to be careful you don't accidentally, skip setting up your drawing in the right orientation and accidentally draw the wrong enantiomer, right? So it's specific to kind of where this ends up. I took it here and just kind of rotated it over, right? All right, so let's kind of talk about that rotation and kind of what you have to do. And then we have some practice ones on the bottom of the page that you can try out whenever you think you got it mastered. So, we're talking about allylic alcohols that could be drawn for you, like so, or squiggled up and down, like so, however they're given to you, and whatever other substituents they might have on them, none, or methyls, ethyls, what have you, you got to kind of take and say, all right, I have to rotate this whole thing, swivel it over, so my orientation, looks like this, kind of set in a plane. And essentially you're always going to put this carbon with its allylic alcohol, which always has to be there for this to work, in your bottom right hand quadrant, if you want to think about it that way. And then all you have to do is, here it is set up just how you need. Look at which enantiomer of your diethyl tartrate you're using. The minus, again, is this molecule, the SS, coming out at you, right? So the minus, the O ends up on top, or it approaches from what we call the top face, whereas the plus enantiomer approaches from the bottom face. So then if you draw, again, these R's it's more exciting if the R's are different things. If you draw like your carbon framework out, if all these R's are methyl, you're not even going to get a chiral center here, although you'll still get one here. If you draw them all out, and then you draw coming off in this direction, kind of away from the OH of the alcohol, right? Kind of pointing away from, coming on the top face, your epoxide, right? There's your top O right there. And then this one, again, like so. It's the O that we're talking about ends up on the bottom face, okay? And the O again is from the accident, or it could end up on the top face if you've got the minus. Okay. All right, so time for you to practice. Go ahead and try these. I'll start working them through. You should try them on your own. Essentially, this one I just added a methyl, and I have it set up real nice for you already, so you should be able to kick through that one. You just have to get the hang of looking at your diethyl tartrate. I kind of just always do this, right? You know, the minus, that's the SS that had the things on the coming out at you wedges. Coming from the bottom face. That was the RR. And we'll do one more where it's minus, so it's coming from the top face. This one, though, you're going to have to kind of rotate it around, aren't you? That's a hint on that last one. All right, you guys go ahead and work these through. I'll pause it, and then we'll come back, and I'll have a separate sheet that has the answers for you.